Which approach is best suited for this multi-output classification task? A. Font style font size 14px independent models train two separate classifiers. One for each output. B. Font style font size 14px multi-output classifier font directly predicts multiple outputs with one model. C. Font style font size 14px classifier chain font trains a chain of classifiers, where each classifier uses the previous classifier's output as an input. D. Font style font size 14px all of the above font. Each approach has its own strengths and weaknesses. False. While simple and efficient in some cases, independent models don't consider potential relationships between outputs. In our scenario, customer feedback could depend on the purchase decision, making independent models insufficient. False. A multi-output classifier offers a powerful way to handle multiple outputs, directly capturing dependencies. It's a strong contender, but not necessarily the only solution. False. The classifier chain is excellent for handling sequential dependencies, where one output directly influences another. If this is a significant factor, it's a good choice. True. The best approach depends on the specific problem and the relationships between outputs. Independent models are simple. Multi-output classifier is efficient, and classifier chain excels with sequential dependencies. D. Font style font size 14px all of the above font. Each approach has its own strengths and weaknesses. A machine learning task where the model predicts multiple target variables simultaneously, predicting both customer churn and their reason for leaving. 30. 5,000. Yes. Poor customer service. 25. 6,000. No. Nah. 40. 7,000. Yes. Price increase. Churn. Reason. A chain of classifiers where each classifier uses the previous classifier's output as input, predicting creditworthiness based on income and then using that prediction to predict loan default. Probability. 5,000. Good. Low. 3,000. Bad. High. 6,000. Good. Low. Income. Credit score. Credit score. Default probability. A Python library for machine learning, providing tools for multi-output classification, classifier chains, and other milliliter tasks. Building and deploying machine learning models in Python. A sklearn class that directly predicts multiple outputs with a single model. Building a single model to predict both customer purchase and feedback, capturing potential correlations between these outputs. Training separate classifiers for each output, ignoring potential dependencies between them. Predicting product purchase based on past purchase history, ignoring customer feedback. Imagine you are building a model to predict a person's health metrics based on various factors. You need to predict both their heart rate and blood pressure. What sklearn technique would you use to achieve this? A. Linear regression. B. Decision tree regressor. C. Random forest regressor. D. All of the above. Linear regression can be used within the multi-output regressor framework to predict multiple outputs. It finds a linear relationship between input features and target variables, which can be extended for multiple outputs. Correct. Decision tree regressor can also be used with multi-output regressor. It partitions the data into subsets based on decision rules to predict multiple outputs. Correct. Random forest regressor, an ensemble method combining multiple decision trees, can be integrated with multi-output regressor for multi-output prediction. It benefits from averaging multiple predictions for better accuracy. Correct. All the listed regression algorithms linear regression, decision tree regressor, and random forest regressor can be successfully employed with scikit-learn's multi-output regressor to predict multiple outputs simultaneously. Correct. D. All of the above. Predicting continuous values like prices, temperature, or age based on input features. Predicting house prices based on square footage, number of bedrooms, and location. Extending regression to predict multiple dependent variables simultaneously. Predicting a person's height and weight based on age and gender. A simple regression model that finds a linear relationship between input features and the target variable. Predicting a student's exam score based on the number of hours studied using a linear equation. A tree-based model that makes predictions by partitioning data into smaller subsets based on decision rules. Predicting the price of a car based on its make, model, mileage, and condition using a decision tree. An ensemble method that combines predictions from multiple decision trees to improve accuracy and generalization. Predicting the risk of a loan default based on various factors like credit score, income, and debt-to-income ratio using a random forest. A scikit-learn class that allows you to wrap various regression models like linear regression, decision tree regressor, or random forest regressor to predict multiple outputs. Predicting a person's heart rate and blood pressure based on factors like age, weight, and activity level using a multi-output regressor with a linear regression model. A popular Python library for machine learning, providing tools for data preprocessing, model building, and evaluation. Using scikit-learn's random forest classifier to build a model that predicts whether a customer will purchase a product. Predicting multiple health metrics. Model a patient's heart rate, blood pressure, and cholesterol levels using factors like age, weight, and lifestyle habits. Stock market analysis. Forecast the closing prices and trading volumes of multiple stocks based on economic indicators, news sentiment, and historical data. Environmental monitoring. Predict air quality parameters like temperature, humidity, and pollution levels using sensor data from multiple locations. Machine condition monitoring. Monitor the health of machinery by predicting vibration levels, temperature, and pressure readings from sensors. You are building a machine learning model to predict both the price and the category of a product based on its features. Which sklearn estimator would you use? A. Linear regression. B. Logistic regression. C. Decision tree classifier. D. Multi-output classifier. E. All of the above. E. All of the above. Multi-output classifier is a method estimator that can be used to combine multiple estimators to predict multiple targets simultaneously. While it is the most direct solution for this specific task, it can also be achieved using other estimators. Here's how. Can be used for predicting the price. It's applicable to continuous target variables. Regression. Can be used for predicting the category. It's applicable to categorical target variables. Classification. Can be used for predicting both the price and category. It's versatile, supporting both categorical and continuous targets. Classification. It is the most direct solution for predicting multiple targets simultaneously. Method estimators. Multi-output classifier. A method estimator that combines multiple estimators to predict multiple targets simultaneously. It's a direct solution for multi-target prediction problems. Estimators. Machine learning algorithms that learn from data and make predictions. Examples include linear regression, logistic regression, and decision tree classifier. Method estimators. Estimators that utilize other estimators as building blocks. Multi-output classifier is an example. Regression. Predicting a continuous target variable. Linear regression is a common regression algorithm. Example: predicting the price of a house based on its size and location. Classification. Predicting a categorical target variable. Logistic regression and decision tree classifier are examples. Example: classifying emails as spam or not spam. Continuous targets. Target variables that can take on any value within a range. Example: the price of a product, temperature, or height. Categorical targets. Target variables that can take on only a finite set of values. Example: product category: electronics, clothing, gender, or sentiment: positive, negative, neutral. Size, brand, color. 100. Electronics, size, brand, color. 50. Clothing. Here's a sample dataset with product features: size, brand, color, price, and category. We want to predict both price and category for new products using these features. What is the purpose of LT font style font size? 16px GTLTB sklearn, multioutput, regress or chain LTB GTLT in multi-output regression. To combine multiple independent regressors into a single model for predicting multiple outputs. To create a chain of regressors where the output of one regressor serves as input for the next. To handle missing values in the target variables by imputing them using a chain of regressors. To reduce the dimensionality of the target variables by applying a chain of regressors. All of the above. To combine multiple independent regressors into a single model for predicting multiple outputs. This is correct as the regressor chain framework allows you to combine independent regressors like linear regression, decision tree regressor, etc. into a single model for predicting multiple outputs. This is one of the ways you can use the regressor chain. Combining multiple independent regressors. To create a chain of regressors where the output of one regressor serves as input for the next. This is correct. It's the core functionality of the regressor chain. The output of one regressor becomes the input for the next, allowing the model to capture relationships between target variables. This chain of regressors helps the model understand how the output of one variable influences the others. Regressor chain provides a flexible framework for multi-output regression by allowing the output of one regressor to be used as input for the next. This chaining mechanism enables the model to capture complex dependencies between the target variables, to handle missing values in the target variables by imputing them using a chain of regressors. This is correct. The regressor chain can help with missing values in target variables. By using a chain of regressors, you can impute the missing values based on the relationships between the target variables. For example, if you have missing values in humidity but the temperature is known, the model can use the relationship between these two to estimate the missing humidity value. Handling missing values in target variables. To reduce the dimensionality of the target variables by applying a chain of regressors. This is correct. Regressor chain can be used for dimensionality reduction in target variables. You can strategically build a chain of regressors to predict a smaller set of target variables, e.g., a combined index instead of individual variables, while still capturing the relevant information from the original set. This is beneficial when you want to simplify the model and improve its efficiency without losing important information from the target variables. Reducing dimensionality of target variables. All of the above. This is correct. All the choices A, B, C, and D are correct. And that's what regressor chain is built for. Regressor chain provides a flexible framework for multi-output regression by allowing the output of one regressor to be used as input for the next. This chaining mechanism enables the model to capture complex dependencies between the target variables. Additionally, the framework supports various use cases, including 1. Combining multiple independent regressors. 2. Handling missing values in target variables. 3. Reducing dimensionality of target variables. All of the above. Multi-output regression. Predicting multiple target variables simultaneously. Forecasting the price and demand of a product, where the price might influence demand. Regressor chain. A method for multi-output regression that chains multiple regressors together. In a medical setting, predicting a patient's blood pressure and heart rate, where these variables could be related and influence each other. Linear regression. A linear model that predicts a target variable based on a linear combination of features. Predicting the price of a house based on its size, location, and number of bedrooms. Target variables. The variables that are being predicted in a regression problem. Predicting the price of a car, the age of a customer, and their probability of buying a specific product, all based on their demographic and browsing history information. Dependencies between targets. Relationships between target variables that can be exploited for more accurate predictions. Predicting both the rainfall and humidity in a region, where higher rainfall often leads to increased humidity. Missing values. Data points with missing values for target variables. Imagine a dataset of customer orders where some orders have missing delivery dates. The model can use the relationships between other variables like order size, product type, and shipping address to estimate the missing delivery date. Dimensionality reduction. Reducing the number of target variables while preserving important information. Imagine you have a dataset with several health indicators like blood pressure, cholesterol levels, and heart rate. Instead of predicting each individually, you could use dimensionality reduction to predict a single composite health score that represents the overall health status of the patient, simplifying the model and potentially improving its performance. Features. Input variables used to predict the target variables. In a house price prediction model, the features could include the size of the house, its location, number of bedrooms, and age of the house. Training data. Data used to train the model. In a spam detection model, the training data would consist of emails labeled as spam or not spam, along with their features like word frequency, sender email address, and links in the email. Test data. Data used to evaluate the performance of the trained model. After training a model to recognize handwritten digits, you would use test data consisting of unseen handwritten digits to measure how accurately the model can classify these new digits. Xtrain. Features for training data. In a stock price prediction model, Xtrain could contain historical stock prices, economic indicators, and company financial data. Ytrain. Target variables for training data. In a weather forecasting model, Ytrain could contain historical temperature, humidity, and wind speed data. Xtest. Features for test data. After training a model to predict customer churn, you would use Xtest to represent new customer data that the model hasn't seen before, to assess its predictive power on unseen data. Imagine we want to predict the temperature and humidity for a given location. We know that temperature can influence humidity. We have data on both temperature and humidity for past days. 1, 25, 60, 2, 28, 70, 3, 32, 80, 4, 20, 50, 5, 22. 55. We can use the regressor chain model with two linear regressors, one for temperature and one for humidity. We can first train the temperature regressor using the data from past days. Then, we use the output of the temperature regressor predicted temperature as input to the humidity regressor to predict the humidity. In this way, we capture the relationship between temperature and humidity to get more accurate predictions for both target variables. In our data example, we can see that as temperature increases, humidity also generally increases. From sklearn, multioutput import regressor chain. From sklearn, linear model import linear regression. Prepare the data. Xtrain 25, 28, 32, 20, 22 temperature features. Ytrain 60, 70, 80, 50, 55 humidity target. Create and train the model. Regressor chain linear regression. Regressor, fit Xtrain, Ytrain. Predict for a new day with temperature 27. Xtest 27. Ypred regressor. Predict Xtest. Printf predicted temperature Ypred 00. Predicted humidity Ypred01.